Welcome to AI Frontiers, Robotics Innovations. This episode focuses on computer science, robotics papers from September 12, 2025. Cutting-edge papers on adaptive robots are explored. Breakthroughs are synthesized into a cohesive narrative. The paper of the day is featured, Diff.RO by Zhang et al. Imagine this. A chaotic warehouse during a blackout, filled with darkness and debris. Suddenly, a robot approaches, listens to a frantic voice command, "Get me to the exit," avoiding the fallen shelves, and guides safely out, without prior programming for that exact scenario. This is not science fiction. It emerges from today's robotics research. Machines are becoming adaptive partners, navigating the unpredictable mess of real life. In this episode, 18 papers from the arXiv preprint server, dated September 12, 2025, are synthesized. The focus lies on computer science robotics, making machines smarter, safer, and more human-friendly. A storytelling adventure highlights innovations, from chatting robots to traffic prediction and tactile tasks. The narrative breaks down the big-picture landscape to nitty-gritty breakthroughs, engaging enthusiasts, students, and those curious about robots in daily life, like folding laundry. This serves as a guided tour through the robotic revolution. Robotics is pictured as the ultimate bridge builder, spanning the gap between cold algorithms and the warm, messy real world. As a subfield of computer science, machines are designed, programmed, and deployed to sense environments, make decisions, and take actions autonomously or with human input. AI and machine learning blend with hardware like sensors and actuators, creating nimble drones for disaster zones or gentle robotic arms for surgeons. Challenges are tackled, such as aging populations needing care, factory labor shortages, and exploration in hostile places like deep oceans or distant planets. These 18 papers, under the computer science, robotics umbrella, showcase boundaries being pushed for wiser robots that improvise in unpredictable settings. Evolution occurs from rigid assembly line bots to versatile companions learning on the fly. The field intersects with AI for smarter decisions, engineering for robust hardware, and psychology for better human interactions. With global issues like climate change, robotics proves essential, transforming industries from healthcare to agriculture. Dominant research themes are distilled into key areas, starting with navigation and path planning in complex environments. Robots are given a built-in GPS that adapts to chaos, like a seasoned hiker reading terrain without a map. Maneuvering through cluttered or dynamic spaces is explored. For instance, a training-free system decodes spoken instructions into graph-based paths, turning vague commands like, "go around the obstacle," into precise routes. Yin et al. Efficient UAV suspended transport in corridors is addressed. Liu et al. Multi-scale spatio-temporal representation learning enables robust robot path planning. Shen et al. The key concept involves graph constraints, structuring space for quick, training-free decisions, handling unpredictability in homes or disaster sites. Human-robot interaction and assistance emerges as a major theme, akin to teaching robots the art of a perfect dance partnership, anticipating moves without stepping on toes. Wearable multi-limb systems coordinate motion for enhanced interaction. Moon et al. Shared control systems infer intent from visual cues during teleoperation, like helping grab distant objects. Fu et al. Datasets and benchmarks capture human-human interaction in physical assistance scenarios. Sadatnayad et al. The technical idea centers on intent inference, predicting user goals from cues for seamless collaboration, making factory robot arms adjust to subtle tugs safely. Simulation and learning-based approaches form another theme, like virtual boot camps training robots in safe digital worlds before real deployment. Efficient simulations for policy learning, self-supervised pose estimation, and pre-training for multi-agent predictions are delved into. GPU acceleration speeds up quadrotor training, parallelizing physics and rendering for agile flight without real-world crashes. Zhang et al. Sensor fusion and perception blend inputs from cameras, radar, lidar, and touch sensors into a cohesive worldview, such as fusing visual and radar data for vehicle segmentation in fog. Montiel Marin et al. Control and optimization ensure robustness, like tuning for low gravity or swinging payloads, with nonlinear predictive control for aerial manipulators or learning-based locomotion for legged robots on lunar surfaces, Arm et al. The concept of differentiable simulation allows gradient-based tweaks for efficient policy learning, bridging raw data to smart decisions in low visibility or delicate scenarios. Key findings are spotlighted as mini-stories. Navigation success rates are boosted by 20 to 30% using graph constraints, allowing robots to decode instructions into paths without training, gaining common-sense spatial reasoning for emergencies, Yin et al. A multi-agent prediction framework disentangles behaviors for accurate forecasting, slashing error rates by 15 to 20% in highway merges, potentially preventing pileups and making roads safer, Shi et al. GPU-accelerated simulation cuts quadrotor training from days to hours, yielding policies that handle windy flights, democratizing drone research, Zhang et al. A digital twin model for tactile sensors improves object classification by blending sim and real data, enhancing accuracy in delicate manipulations like robotic surgery, Huang et al. Shared control in teleoperation infers user intent from visuals, reducing task times and errors for intuitive remote manipulation, expanding capabilities for disabled operators, Fu et al. Learning-based controls enable legged robots to traverse lunar-like terrains with minimal energy, advancing space exploration. These highlight robotics' leap toward reliability. The paper of the day is decoding, a GPU-accelerated differentiable simulation framework for efficient quadrotor policy learning, by Shinong Zhang et al. 2025. The objective addresses robust control policies for quadrotors handling chaos like gusty winds or obstacles. Slow simulations hinder reinforcement learning, often taking days on expensive hardware, lacking full differentiability for gradient backpropagation. CPU bottlenecks occur while GPUs remain idle. The framework creates a lightweight, GPU-powered setup parallelizing physics to rendering, enabling end-to-end differentiable learning. Inspiration draws from gaming engines for seamless physics. Accessibility is targeted for hobbyists and small teams, accelerating aerial robotics innovation. decoding features a unified simulation stack that is fully differentiable, with components like rigid body dynamics, sensor models such as IMUS and lidar computing gradients automatically. GPU parallelism operates at environment and agent levels for multiple sim instances and drone swarms. Neural network augmented dynamics models approximate complex aerodynamics differentiably, avoiding simplified physics inaccuracies. Reinforcement learning algorithms like PPO are integrated, with policies learning from simulated rollouts. Domain randomization tweaks parameters like wind or mass to mimic variability, and a real-to-sim pipeline uses neural networks to match physical behaviors. Benchmarks against Pi Bullet or Mu Joko occur on consumer GPUs like NVIDIA RTX 3090, testing aggressive maneuvers like flipping through hoops or recovering from tumbles. Findings show jaw-dropping speedups of 10x to 100x compared to baselines, with stable flight policies learned in 2 to 4 hours on standard hardware. Benchmarks yield 95% success rates in maneuvers, outperforming non-differentiable sims in trajectory error and energy efficiency. Real-world transfers maintain stability in 15 meters per second winds, reducing sim-to-real gaps by 25% via learned residuals. Scaling to 1,000 parallel environments is achieved. Limitations include potential overfitting to GPU quirks and challenges in ultra-complex interactions like fluid dynamics. Significance democratizes research, empowering underfunded labs for faster developments in delivery, monitoring, or urban mobility. Ingenuity overcomes hurdles, inspiring new generations and paving ways for hybrid learning in other domains. Future directions point toward hybrid human-AI systems blending intuition with robotic precision, evolving into swarms coordinating disaster relief like synchronized birds. Scalable multi-robot networks for planetary exploration may feature lunar walkers adapting in real time. Robotics is analogous to the next internet, connecting disparate worlds from factories to far-off planets, fostering innovation and sustainability. Challenges like ethical AI use and energy efficiency must be addressed, but the trajectory promises robots enhancing human life without replacement, evolving from tools to allies. The Journey Through September 12, 2025's Robotics Papers recaps navigation breakthroughs like graph constraints, Yin et al., interaction advancements, and simulation speedups, Zhang et al. Robots are gaining finesse in listening, predicting, and touching to tackle real-world challenges with AI smarts. The initial warehouse scenario draws nearer. Transformation lies ahead, with bots as everyday allies. Papers should be explored. Links in show notes, or thoughts shared with #AI Frontiers. Exploration of the saga continues. What happens next? This deck was synthesized using AI tools. GPT-Grok with model Grok 40709. TTS synthesis was handled via Google for audio elements. Image generation utilized OpenAI for visuals. Human expert review was undergone. Possible oversights may exist. All references are provided in show notes for verification. Subscribe to stay updated on AI and robotics breakthroughs. The channel is AI Frontiers. Follow for deep dives, syntheses, and discussions. Share thoughts and join the community today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.